Welcome to a replay of supernodal analysis, and I'm sure this time this video will now have my voice. Okay, so for supernodal analysis, what do we need to know about supernodes? When do we apply supernodal analysis, and how do we apply the previous steps we learned from nodal analysis to networks with supernodes? Okay, those are the things that we'll be able to learn in this video. So let's move to the next slide. Supernodal analysis is used, okay, if you have a voltage source, okay? If you have a voltage source in between, maybe the voltage source is either dependent or independent, any of the two, okay, is considered a supernodal provided that that voltage source is connected between two non-reference nodes, okay? Between two non-reference nodes, please correct this spelling. These two non-reference nodes, we call them a supernode, or they form a generalized node. And we know when you say generalized node, you have two nodes which are connected by a short circuit, 'di ba? Wherein doon papasok yung natutunan natin that if you have a generalized node, that generalized term may also be known as similar. So previously, when we learned about short circuits, you know that similar node or common node, okay, you know that nodes are common or similar if in between two nodes is walang nakalagay na element kundi wire lamang, di ba? So if this is node A, this is node B, and in between these two nodes, you have nothing in between them but a wire, ibig sabihin this will represent a short circuit, okay, because you have a simple circuit or a short wire that connects two junctions, meaning they are just common or the same node. Okay? So kapag daw po, in supernodal analysis, kapag daw po ang network, di ba previously in the nodal analysis, nagsaset tayo ng isang reference node or ground node. And then the rest of the nodes remaining, yun yung ating mga nodes na kinukuha na natin ng KCL. In this case, para malaman mo daw kung alin ang magiging supernode, kapag daw po ang nodes na meron ka, let's say for example again, node A and node B, sa pagitan ng dalawang nodes na ito, ang laman lamang niya ay voltage source. Okay, either dependent or independent ang voltage source mo, then these two nodes will form a supernode. Okay? Now, to differentiate this from the mesh analysis, okay, sa mesh kasi, ang ginagawa natin, when you have a current source in between two nodes, ino-open circuit natin siya, di ba? Dito, when you have a voltage source in between two nodes, you short circuit, okay, that part or that branch. So, magiging ganito na lang siya. Kumbaga parang marireplace si voltage source by just a wire. Magiging wire lamang siya. And notice or please know that kailangan po ang laman ng dalawang nodes or ang nasa pagitan ng dalawang nodes ay voltage source lamang. Okay? Hindi pwedeng may resistor. Kasi unlike with mesh analysis, di ba sa mesh, if this is a current source and then you have a resistor here, it's fine. You can still open circuit this and apply super mesh. Kasi kapag in-open circuit mo tong current source, mo-open yung buong branch. Pero dito, okay, dito, ang kino-consider lang natin with supernodal analysis is a branch or in between two nodes na ang laman ay voltage source lamang. Hindi pwedeng may kasama siyang ibang element. Okay? And if these two nodes, okay, has voltage source lamang, we can call this a supernode because we can short circuit. Okay, we can short circuit the voltage source, and when it becomes a supernode, and then it becomes a supernode or it becomes a common node or a generalized node. Okay, so again, same with mesh analysis, i-mentally short circuit lamang po natin siya when we are doing KCL. Okay, so we're going to apply Kirchhoff's current law, similar to what we were doing previously with the nodal analysis topic, di ba? Nag-a-assign tayo ng nodes, nag-a-assign tayo ng directions of current flow. After that, the first thing we do is take KCL on all available nodes except the ground or the reference node. So, ganun pa rin po ang steps, walang nagbago. Just remember that, again, ang sinusupernode lang po natin na voltage source, Okay, or ang short circuit lang po natin na voltage is yung voltage na connected sa pagitan ng dalawang non-reference node. So, ibig sabihin, kailangan yung voltage source mo hindi nakakabit sa ground or sa reference node natin. Kailangan siya ay nandun sa non-reference nodes. Okay? And then again, we apply KCL and KVL to be able to determine the node voltages, which is our agenda in the nodal analysis. Okay? So, let's have the examples. Okay, and we have here the first example, or example 3.18 in your book, which is, I think, if I remember it right, this is the same circuit we had in mesh analysis. Ano po? So, since this is a replay, I already have the copies pasted on the blank pages that we have, and I just erased the solution I did. So, what I'm going to do is apply the same solution, apply the same assumptions of currents I did from the previous video, so that there's no need for me to re-upload notes. Okay? So, for problem 3.18, we're being asked to find the branch currents. Ang steps po natin ay ganun pa rin. Okay? Nothing changed with the steps. Okay, so before we proceed, the first thing we have to do is apply. Okay, the first thing we have to do is, of course, apply the labels for our nodes and the directions for our current. Pero, what I'm going to do first is solve this problem using nodal analysis. So, hindi pa ako nag-supernodal dito, although you have a branch here that contains voltage lamang. Pero as you can remember, pwede naman natin itong isolve using nodal analysis din. So, that's the first thing I'm going to do. Okay? Using nodal analysis, I am going to label the nodes that we have here. So, I'm going to label this node A. This one is node B. B nga. And then the other one is node C. And then I'm going to put the bottom node as my reference node. Okay, after that, let me assign the directions of current. I have this I sub 1. This is I sub 2. And then I have I3. I have I4. And then I have I5 here. And then I6 is on the branch with the voltage source. Okay? So, ipapakita ko lang yung nodal analysis ulit para makita nyo kung ano yung difference sa solution ni nodal at saka ni supernodal. Okay? So, dito, sa nodal analysis, as you can see, we have the voltage source na tinutukoy ni supernodal as could be a supernode, which is connected to the reference node. So, ibig sabihin, if your reference node is positioned here, hindi mo ito actually pwedeng i-supernodal. Ano? Kasi again, pwede ka lang mag-supernodal if this voltage source is in between two nodes which are non-reference or non-ground nodes. Okay? But since this is nodal analysis, we're going to continue with what we've been doing. So, diba sa nodal analysis before, sabi natin, in nodal analysis, it's easier to have a branch that has voltage source lamang be connected to the ground because it leads us to an inspection wherein we apply nodal, wherein we apply KVL, diba? So, by inspection, okay, I'm sorry if you're hearing friction with my pen and my device. I actually changed my screen to paper-like para naman feel ko yung magsulat tsaka medyo maganda yung sulat ko, in fairness naman. Okay, anyway, so we're going to inspect and do KVL. Remember, we are under nodal ha. So, ibig sabihin, that would be VB, okay, minus 12 volts, okay, minus 0 equal to 0. So, that would be V sub B minus 12 volts minus 0 equal to 0. And that leads us to an answer for VB, which is already 12 volts. So, with a branch that has a voltage source lamang, it's easy for us to use nodal analysis if it is connected to the ground or to the reference node, because by inspection, may value na agad na tayo doon sa node voltage ng kabilang side. Okay? So next, anong sunod natin ginagawa? What we do is we take KCL, right? Actually, KCL talaga yung una nating ginagawa before. Okay? Inuna ko lang yung inspection para lang mapakita ko agad sa inyo the difference between supernodal and nodal. Okay? So, ang difference ay ito. In nodal, in nodal, what we do is we make sure that this voltage source is connected to the ground so that we can apply KVL or inspection to it. In that case, you'll be able to solve for 1 voltage agad. Okay? Sa supernodal, hindi pwedeng itong branch na ito na voltage source lamang ang laman ay nakakabit sa node. Ay nakakabit sa ground. Okay? But anyways, the first step is still to take KCL on the remaining branches or on the remaining nodes. So of course, let's start with KCL at node A. Okay, so if we take KCL at node A, you have there negative I sub 1. And then I2 is entering, so positive. And then you have positive I5. Okay, so let me write that. That is negative I1, positive I sub 2, positive I sub 5, and then equate it to 0. After that, after writing my equation, my current equation, I will have to equate this to its Ohm's law expression, diba? So for I sub 1, I'll be tracing A to B nodes. So that would be VA plus 10 volts minus VB all over 10. Okay, so I have here negative of the quantity. So we started at VA plus 10 volts minus VB all over 10 plus I2. So for I2, I have to trace the ground going to node A. So that would be 0 minus VA over 15. Okay, so we have 0 minus VA all over 15. Next, plus, you have I5. For I5, you have to trace node C papuntang node A. So you have there VC minus VA all over 5 ohms. And then, following the equations, we have equate it to 0. Okay, after that, ganun pa rin, we expand, diba? We expand and apply necessary values lalo na doon sa mga quantities na nasolve na natin. So, by expansion you have to distribute the negative sign here. Okay, so you have negative VA over 10, negative 10 over 10, positive VB. So for VB, I'll apply 12 volts na because you have an answer already for that, all over 10. Okay, plus 0 minus VA, so that's negative VA over 15, plus VC over 5 minus VA over 5, and then equate this to 0. After that, we group like terms. So I'm going to factor out VA from all terms containing VA. And that's negative 1 over 10. Negative 1 over 15. Okay? And then negative 1 over 5. So you have negative 1 over 5. Okay? Plus, I still have VC. One term which is VC, that's 1 over 5. And then I'm going to transpose all constants to the right. So remember you have here negative 1 transposed to the right makes it positive 1. Okay, and then minus 12 over 10, or you can simplify that as 6 over 5. Ano po? Then I'm going to box this as your equation number 1. Okay, next. We're going to take KCL on the other node that is left with us, which is node C. So, we don't need to KCL on B because we have already solved its node voltage. Sa C na tayo. So, sulat ko lang din dito sa left side. Similar to what I did in the notes that you already have. So, I'm going to take KCL at C. For KCL at C, I have there positive I3, negative I4, and positive I sub 5. And then equate that to 0. If I need to explain that, I3 is entering, so it's positive. Negative si I4 leaving, negative si I5 leaving. Negative si I5 leaving. So let me correct this. Okay. Next, let's apply the Ohm's law expression for each currents. We have, for I sub 3, we have VB minus VC all over 12. Minus for I4. For I4, you have VC minus 0 all over. So you have two resistances there, 11 and 10 ohms. So we add those as 21 ohms. Minus I5. I5 is again VC minus VA all over 5 ohms, and then equate this to 0. Next is we have to expand the equations that we have. So we have here VB over 12. We know that VB is already 12 volts. So we have 12 over 12 minus VC over 12. Do not forget to distribute the negative sign. Pero anyways, this is 0 naman. So it's simply negative VC over 21 minus, so distribute the negative sign again. That's negative VC over 5, and then negative and negative, that will be positive VA over 5. Okay, and then equate that to 0. And then group together like terms. Again, pwede kong kuhanin si VA. And it's just a single term. That's VA over 5. So I have here 1/5. Plus, I'll factor out VC from all terms containing VC. So that would be this 3. So you have there negative 1 over 12, negative 1 over 21, negative 1 over 5. Okay. And then equate this to the right side. Please check if you still have constants in your equation. This one is a constant. So you move that to the right. It becomes negative 1 if you simplify it. And this becomes your second equation. Okay. After having two equations, we are going to use our calculator to solve for VA and VB. Okay, let me bring out my calcu if I can do that here. Systems of equations with, this is two unknowns. So you have this equation, negative 10 inverse, okay, minus 15 inverse, minus 5 inverse equals, for VC, I have 5 inverse. And then I have a constant at the right side, which is 1 minus 12 over 10. That's my first equation. My second equation is on my left. That's VA with 5 inverse. VC has negative 12 inverse, minus 21 inverse, minus 5 inverse. And on the right side, I have a constant, which is negative 1. Press equals. So you have VA, which is, let's check yun, pwede siyang fraction. So it's always choose to present your answers in fractions ha, para it's not difficult for us to store them again. And we still retain the exact quantities. So this is in volts. And then yan, wala tayong ano dito. Wala tayong option but to have 4.9990 volts. Okay, we cannot store this. Okay. It can be in fraction pala din. So let me just rewrite that as 5124 all over 1025 volts. Okay, next. Let's move. After being able to solve for VA and VC, we now can solve for the currents, right? So let's start with I sub 1. So similar to the notes that you already have, I've written I sub 1 on the right side of my paper. And that is I1 equal to, so we have I sub 1, which is equivalent to, you can go back to your circuit to trace again, or you can just go back to your equations. So ito yun. Do not include the negative sign outside. So that's VA plus 10 minus, that's minus 12. Diba? VA plus 10 minus VB all over 10 ohms. So substituting, that will result to VA is 3354 over 1025 plus 10 minus 12 volts divided by 10. If you press that in your calculator, which I'm not going to do anymore, you will get I sub 1, which is equivalent to 652 all over 5125 amperes. Okay. Next, you can now solve for I2. And I2 is equivalent to, what's I2? 0 minus VA all over 15. So substituting our values, that's 0 minus 3354 all over 1025, and then divide that by 15. Let me move the equal sign here in the main fraction bar. And then using your calculator, you'll be able to get that I2 is equivalent to the negative of 1118 over 5125 amperes. Okay, next is we can solve for I3. Okay, maybe I can place I3 here. So solving for I3, that would be VB minus VC all over 12. I'm just looking here at the equations or expressions I've made in the solution. So that would be substituting, you have VB equals 12 minus VC, which is, okay. Let me correct this. This is supposed to be VC. Ano po? The variables that you have in your equations. Okay. VB, which is 12, minus VC, which is 5124 over 1025. And then divide this by 12 ohms. So I3 will be equivalent to 0.5834 amperes. Next to that is we can solve for I4. And I4 is equivalent to VC minus 0 all over 21. And VC is 5124 over 1025 minus 0 all over 21 equals, our answer for I sub 4 is 0.2380 amperes. And then last but not the least, we can now solve for I5, which is equivalent to this one. So you have there VC minus VA all over 5 ohms. And that by substitution would be equivalent to 5124 over 1025 minus VA, which is 3354 over 1025. And then all over the resistance, which is 5 ohms. And then you'll be able to get the current in the our fifth current, which is 0.3454 amperes. Okay, so actually from the designations you have 6 currents, so we still have to solve for I6. And what we do to solve for I6 is we take KCL here since you already have currents in the branches at the sides. In that way, you'll be able to solve for I6. So if you take KCL at B, okay, this time we can take KCL at B. You'll be able to get that at B, you have I6 entering, I1 is entering, so that's I1 positive, I6 positive. And then on the right side, you have I3 leaving, so minus I3. Okay, and then equate that to 0. So by solving for I6, that would be equivalent to I3 minus I1. And getting the values for I3 and I1, I3 is 0.5834 amperes minus I sub 1. I sub 1 is 652 over 5125. So we have 652 all over 5125 amperes. You'll be able to solve for I6 in your calculators, and that's equivalent to 0.4562 amperes. You can go back to our nodal analysis and check if this is the same answer that we had, or I'm not sure if this is already available in the mesh analysis. You can also check there. So the point is, whatever method you use, the same answers should appear as the respective branch currents in the network. Okay, so kung ano man yung nakuha mong value for this branch, kung ano man yung value ng kuryente na nakuha mo for this branch, that should be the same value you'd be able to get any method that you do. Okay, do not compare your answers based on the labels that you assigned for them. Kasi pwede mag-iba-iba yan. At least, kung saan mo nilagay si I2, let's say dito sa branch na to, okay, kung ano man yung label ng branch na to, in the other methods that you use, they should have the same answer, which is negative 1118 all over 5125 amperes. Okay, and again, this solution is not supernodal. This is nodal analysis. Okay, so this time, let me show you how you are going to solve this same circuit if we are going to apply supernodal. Okay, so if we are going to do supernodal, okay, using supernodal, of course, you have to strategically place your ground or your reference. This time, you cannot anymore place the ground here. It is not anymore allowed if you wish to use supernodal. Bakit? Because the focus on supernodal is the branch that contains just the voltage. So, itong branch na to, it cannot be connected to the ground. Therefore, let me label the nodes for you. This is node A, this is node B, this is node C, and this is node D. And thus, Do not use, okay? Do not use B and D as grounds because they are connected to the branch that contains the voltage source only. Okay? Do not use B and D as grounds or as ground to be able to proceed to apply supernodal solution. Okay? So, ibig sabihin, you can either choose in between node A and node C as your ground. So, in the previous session, I chose node C as my ground. So, I'm going to place here my schematic symbol for the ground. Okay. After that, let me assign the same directions of current we assigned from here para lang madali tayong mag-compare. Pero actually, you can assign any direction pa rin. Ano? So, for easy comparison later of our answers, I'm going to place the same assumptions of current. Okay. You have to the left here is I sub 5 and then you have upward which is I6. Next. So, in this case, we already know that BD will be supernodal. Okay? Because it contains just a voltage source. So, in this case, it is an independent voltage source. Thus, I'm going to note here supernodal at BD. Supernodal at BD, what would happen? You will have to mentally short circuit si 12 volt source. When you say mentally short circuit, ibig sabihin, you will short circuit the branch or remove the 12 volt voltage source and replace it by a wire. So to show you that, para madali nyo siyang makita, papakita ko siya dito sa inyo. Gagawin ko, I'm going to erase this. Let me use a white pen for that. Okay. Uburahin ko to guys para makita nyo yung ibig sabihin ng sinasabi ko. So, sa isip nyo, ganito ang gagawin. Uburahin nyo siya mentally. And then, you're going to replace it by just a wire. Okay? Replace it by just a wire. Yan. Ganyan po yung mangyayari dyan. And then, let me just copy again the nodes that we have assigned. So, this is AB ground. AB ground. And then, this is node D. And then again, you have I1, I2. You have here I6 na hindi ko muna ilalagay because it's not yet existing. And then you have here I3 and then this one is I5. Okay. So if supernodal na natin si BD, we're going to KCL naman. Okay. I-move nga natin ito ng konti para medyo maluwag. Yan. Okay. So, the next thing we're going to do is after mo ma-supernodal, edi tayo ay mag-KCL na. So, always start your KCL at the branch considered, at the node considered a supernode. Therefore, we're going to KCL at supernode BD. So, B and D is now known as a supernode because they are a common node. Ibig sabihin, kapag nag-KCL ka dito, lahat ng nakakabit sa kanilang branch, yun ang mga kuryenteng kukuhanin nyo. If you're going to look at node B, dalawang branch yan. And if you're going to look at node D, dalawa ding branch yan. In short, your KCL equation must contain 4 currents. Okay? Kasi 4 na branch yan. In short, lahat ng nakakabit sa supernode kasali sa KCL. Kumbaga lahat sila, kahit magkakaiba ang pwesto, iisa yung pinapasukan nilang node. Okay? So you have, let's start with I1, it's entering. So that's positive I sub 1. I3 is leaving, so that's negative. I2 is entering node A, so I2 is leaving node D. Okay, BD tayo ha. I2 is leaving node D, kaya negative I2 yon. And then I4 is entering node D, so it's positive I4. After that, we equate to 0. And then, proceed with the usual. So, we're going to represent or express each of the currents. To their Ohms law expression. So, let's start with I sub 1. I sub 1 is VA minus VB. I sub 1 is VA plus 10 minus VB all over 10 ohms minus the quantity of I3. I3 is 0 minus VB. Hindi ko nakita ng maayos. Ano ba yan? Ito yung arrowhead. Okay. I3 is VB minus 0 all over 12 minus I2. For I2, you have there from VD, papunta siya sa node A, diba? So VD minus VA all over 15 ohms plus I4. For I4, galing siya sa ground. So you have there 0 minus papuntang D all over the sum of the resistances again, which is 21. And then we're done with the left side of the equation. You can now equate this to the right side, which is 0. After that, yun pa rin, we're going to expand. So similar to what we've been doing. Ano nga? Walang nabago. Ang nabago lang is, alin yung i-KCL mo or paano mo i-apply? Alin ang iso-supernodal mo? Paano mo siya i-apply? Anong gagawin? Iso-short mo siya. And then you take KCL on that supernode. Okay? And then the rest of the process is the same. So, expanding, you have VA over 10. Okay, plus 1, that's 10 over 10. Minus VB over 10. Minus, distribute the negative sign, VB over 12. Okay, minus VD over 15. Plus, if you distribute the negative sign, that's VA over 15. Okay, minus VD all over 21, and then equate that to 0. After that, group together like terms. So I'm going to group all VAs, and that would be 1 over 10 and 1 over 15. Okay, plus all VBs. So you have there negative 1 over 10, negative 1 over 12. Okay, and that's it. Plus, we also have VD. So for VD, we have two terms then. You have negative 1 over 15. And then you also have negative 1 over 21. And then equate this to the constant at the right side because you have a constant here. So you move it at the right, it becomes negative 1. Okay, and then I'm going to box this so you know that this is our first equation. This is your equation number 1. Okay, next. After taking KCL from the supernode, of course, you have to proceed with KCL at the other nodes pa. So in this case, ang tira mo na lang node na pwedeng pag-KCLan is node A. So we KCL at node A. And if you're going to look at node A, you have there negative I sub 1. Negative I sub 1. You have positive I sub 2. And then positive I sub 5. And then equate that to 0. Okay? So tracing, you get there negative of I1. I1 is VA plus 10 minus VB all over 10 ohms, this is actually similar to the nodal analysis we did kanina. Previously, plus I2. So for I2, ang difference lang, hindi na 0. Kasi ito, kanina, 0 siya 0 minus VA. This time, magiging VD na siya, no? So that's VD minus VA all over 15 ohms. Plus I5. I5 ngayon is galing na sa ground. Diba? Dito na siya galing. Papunta doon. So 0 ngayon yan. Okay, so you have, for I5, that is 0 minus VA all over 5 ohms. And then equate that to 0. And then we expand. So we distribute the negative signs. And that would be negative VA over 10. Negative 1. Positive VB over 10. Positive VD over 15. Negative VA over 15. Negative VA over 5. And then equate that to 0. Afterwards, we factor out or group together like terms. So I have VA terms here from negative 1 over 10, negative 1 over 15, at saka negative 1 over 5. Okay. Plus VB terms, meron tayong isa. So that is positive 1 over 10. And then we have VD term na isa din. Plus VD, which is 1 over 15, positive 1 over 15. And then equate that to positive 1. Okay, because of this one. Transpose it to the right, becomes positive. And this is officially your equation number 2. And if you're going to notice, okay, tatlo yung variables natin. Kaso, dadalawa pa lang yung equations. So you have 3 variables, which is VA, VB, VD, but dalawa pa lang equations natin. So after that, ano ang sunod na gagawin? Okay? So after mo mag-KCL sa lahat ng available nodes na meron ka, you go back to the original circuit, the one wherein hindi naka-short si 12 volts. So hindi na ito ang gagamitin natin. Or mentally, ibalik nyo Kasi 12 volts, so babalik tayo dito. And after all the KCL, syempre, ang next option natin is to do KVL. So, KVL saan? At the supernode. Okay, KVL at BD. I-include ngayon natin sa analysis yung ating voltage na inales. Ano? So, pag nag-KVL tayo using nodal principle, that would be VB, okay, plus 12 minus VD equal to 0. So, rearranging the terms, you have here VB minus VD equals negative 12. Sorry. Ito pala ay negative 12. Okay, ulit. VB minus 12 minus VD equal to 0. So, we transpose this to the right. It becomes positive 12. Okay, positive 12. And let me box this for your third equation. This is equation 3. So, you now have 3 equations, 3 unknowns. And I'll ask you to pause the video and then solve for VA, VB, VD using your calcu. And now, if you have solved it, double check natin yung na-try nyo sa calculator nyo. So, it should be VA, which is negative 354 all over 205 volts. VB should be 7176 all over 1025 volts. And VD should be negative, I think this is your 5125 all over 1025. Okay, similar doon sa kanina, which is 4.9990. Okay, yan. So, remember, do not expect po that the same node voltages yung makukuha nyo. Kahit na iisa yung positions ng labels. Diba? Halimbawa, pinangalanan mo to ng VA, VB. Dito ay VA, VB din siya. Do not compare their answers and do not think that their node voltages will be the same. Okay? Magkaiba palagi yan. Why? Because nag-iiba yung pwesto ng zero potential or ng ground, and alam naman natin pag potential energy, siya ay distance-based, 'di ba? Actually, elevation nga siya eh. So, ang ground mo, which is considered in the ground or in the nasa lupa horizontal, ibig sabihin nasa taas niya si VA-VB. So, mag-iiba yung mga values ng potential energy niya, which is your voltage. Kaya lagi yang magkakaiba. Okay? Next. So, after natin na makuha yung VA, VB, VD, pwede na natin kuhanin lahat ng currents na meron tayo. Okay, so let me do that for you. Let's start with I1. Okay, so for I1, that is VA plus 10 minus VB all over 10. I'm just looking at the equations at the top, dito sa medyo right side. That's equivalent to VA, which is negative 354 over 205 plus 10 minus VB, which is 7176 all over 1025 all over, okay, 10 ohms. And that gives us an answer which is 652 all over 5125 amperes. And this I1 na ito din yung I1 natin doon sa nodal analysis natin, which is also 652 all over 5125. So, doon nyo i-compare yung methods nyo kung tama. Doon sa currents na makukuha nyo in every branch. Ano po? Next, you have I2. Okay, I2 is equal to, I2 is VD minus VA all over 15. Okay, VD is negative 5125 all over 1025 minus VA, which is negative 354 all over 205. All over 205. And then, all divided by 15 ohms. And you'd be able to get I2. And I2 is supposed to be negative 0.2181. Okay? Next to that, pwede na nating isolve si I3. Okay, so balik tayo sa taas. What's I3? I3 is VB over 12 or VB minus 0 over 12. Ano? I3 is VB minus 0 over 12, and that's equal to, what's VB? VB is 7176 all over 1025 minus 0 all over 12 volts. And that's equivalent to, in fraction, that's 598 all over 1025 amperes. Okay, next is we solve for I4. And that's in expression, alin yun? Okay, I4 natin is 0 minus VD all over 21. Diba? 0 minus VD all over 21. And that's equivalent to 0 minus, what is VD again? VD is negative 5125 all over 1025 all over 21 ohms. And that gives you a value which is equivalent to 0.2380. Unit, of course, amperes. Okay. Next is, you have I5. Okay, balik tayo. I5 is 0 minus VA over 5. Ito siya. 0 minus VA over 5. So, 0 minus VA over 5. And that's equivalent to 0 minus the quantity of what's VA. VA is negative 354 over 205. Okay. All divided by, 5 ohms. And you'll be able to get your current, your fifth branch current, which is 354 all over 1025 amperes. And then lastly, for I6, balik ka sa circuit, edi ganun pa rin po, KCL pa rin. So as you can see, if you KCL at B, that would be positive I1, positive I6, negative I3. So in short, I6 is simply I3 minus I1. Ano po? Okay, idadiretso ko na guys ha. Because I know for sure now understand what to do. So I6 will be equivalent to I3 minus I1. Okay, and that is, what's I3? I3 is 598 all over 1025 minus I sub 1. I sub 1 is 652 all over 5125. And that gives you your sixth branch current, which is 0.4562 amperes. And that completes all our answers na if you compare sa taas, so that pare-pares yung sagot natin, no? I1 is already correct. I2 is negative 1118. Let's check that. Mode math. 1118 divided by what? Divided by 5125. Okay. In decimal, that's 0.2181, which is similar to what we have. Negative din ba? Okay, correct. Negative. And then you have I3. I3 is 0.5834. I4 is 0.2380. So, almost everything is similar naman, di ba? Okay. So, that's the difference. Syempre, if you're going to compare this solution to this solution, for this circuit, this is easier. Simpleng nodal analysis is easier. But then again, as I've told the other sections last time, supernodal analysis will still be very useful, lalo na if the circuit is very complicated. So, hindi tayo pwede makulong on just nodal analysis dahil sa tingin natin, on this particular circuit, mas madali siya. Syempre, on other circuits, mas magiging mas madali para sa atin gumamit ng supernodal lamang. Okay? And that's example 3.18. Next, let's proceed to the next circuit, which is example 3.19. And in here, you now have a dependent voltage source. So the idea under this example is, how do we solve a network with a dependent using supernodal? Okay, so syempre tayo dito ngayon ay magsa-supernodal na. Hindi na tayo magna-nodal analysis, kasi na-compare na natin siya. So what are we going to do? So the first thing we're going to do is assign our nodes. So I'm going to assign the following as A, B, and C. And in this case, okay na gamitin natin yung ilalim as the ground because yung atin naman pong voltage source ay nandun talaga sa non-reference. So, ang non-voltage, ang reference, tawag dito, nabubulol na. Ang ating voltage source is dependent at nasa pagitan siya ni AB. So, obviously, dito tayo magsusupernodal. Okay? Pero before we do that, let me assign the directions of the currents. Let's say this is I1. This one is I2. This one is I3. This one is I4. We have this one as I5. And then we have this one as I6. Okay? Next. Oh, of course, the branch with the voltage source, let's say this is I7. Okay, after assigning your label, your nodes, determining your reference point or your ground, we can now proceed, and your directions of current, we can now proceed with the first KCL in the supernode. So, syempre, supernodal natin si node AB, meaning, mentally, iso-short circuit natin si C3VX. Okay. So, mentally short circuit, kayo na ang gumawa nun sa isipan nyo, magiging wire na lamang to. Which means, we're going to KCL at supernode AB at lahat ng nakakabit kay A at lahat ng nakakabit kay B ay kasama sa equation. Ano? So, KCL at supernode AB. Okay, and that will result to, punta tayo kay A muna. So, kay A, tatlong branch yan. I1, I2, I6. So, positive I1, negative I2, and negative I6. After that, proceed to node B. Kay node B, tatlo din yan. So, you have I4, I3, I7. Kay node B, dalawa na lang, ano? So, you have I4, I3. Siyempre, hindi nyo isasali yung branch na shorted kasi nga common. Wala nang, kumbaga parang sabihin natin, wala munang current doon. Okay, so you have there negative I3 and negative I4. And then equate that to 0. After that, get the Ohms law expressions of the following. So, for I1, that is 0 plus 50 minus VA all over 12 ohms. Diba? 0 plus 50 minus VA all over 12 minus I2. So, for I2, that's VA minus 0 all over 15 ohms. This is I2. Next is I6. Ito si I6. Ito pala. From A to C pala siya. So, that would be minus I6, that's VA, minus VC all over 10 ohms. Minus I3. I3 is from node B papunta sa ground. So, you have there VB minus 0 all over 10 ohms minus I4. For I4, that is from B to C. So, you have there VB minus VC all over 12 ohms. And then, equate that to 0. Okay? The next thing we're going to do is, of course, expand the equations we've made. So, we'll start with 50 over 12 minus VA over 12 minus VA over 15 minus VA over 10. Don't forget to distribute. So, negative, negative, positive na si VC over 10. Then, we have negative VB over 10. Negative VB over 12, distribute the negative sign, negative, negative, positive VC over 12. And then equate to 0. After that, group all together the VA terms. So you have there negative 1 over 12, negative 1 over 15, negative 1 over 10. Okay, next is plus VB. In VB, you have negative 1 over 10 and negative 1 over 12. Okay, plus VC. So, for VC, you have there 1 over 10 plus 1 over 12. And then, check if you have constants. So, we do have constant. This is 50 over 12. So, you transpose that to the right. And it becomes negative 50 over 12. And we underline this as your equation number 1. Okay. After that, anong sunod nating step? After mo mag-KCL doon sa supernode, lahat na ng tirang nodes ang kasunod. So, okay na tayo dito. Ito na lang ang tira. We do KCL at node C. KCL at node C. And you'll get there positive I4, negative I5, positive I6. And then equate to 0. If I need to trace that for you, that's positive I4, negative I5, positive I6. And then we replace the currents with their Ohms law expressions. Ohms law expressions. So you have there for I4, that's VC. For I4, that's VB, sorry. Ito. Okay, that's VB minus VC all over 12 ohms minus I5. So, ang I5 natin ay from here to the ground. That's VC minus 0 all over 5. So, VC minus 0 over 5 plus I6. For I6, that's from A to C. So, you have there VA minus VC all over 10. Okay, and then equate that to 0. After that, we expand. So, that's VB over 12 minus VC over 12 minus VC over 5 plus VA over 10 minus VC over 10, and then equate that to 0. Group together like terms. I'll take out VA, that's 1 over 10 plus VB, ilan yun? Isa lang, that's 1 over 12. And then you have several VCs, tatlo sila. So you get negative 1 over 12, negative 1 over 5, and negative 1 over 10. And then equate that to the constant on the right side. Meron ba? Wala. So we have 0. And then this will be our equation number 2. Checking the equations that you now have. You have 2 equations but you have 3 variables, diba? VA, VB, VA, VB, VC. And as I've said kanina, okay, after mo mag-KCL sa lahat at kulang ang iyong equations, go back to the supernode branch at doon ka mag-KVL. Okay, KVL na ang kasunod kasi tapos na tayo mag-KCL, no? So, KVL at node at the supernode AB, ibabalik na natin si voltage source. And then, pwede na tayo mag-KVL, di ba? Pag naibalik na si voltage source, dito na tayo mag-KVL. Using nodal KVL, you have VA plus 3VX minus VB. So, let me write that down. That's VA minus 3VX minus VB. And then, equate that to 0. Okay? The issue here in this equation is that you have an additional, unlike kanina na nabuo niya yung equations natin na tatlo, you have an additional variable. Kasi dapat supposedly VA, VB, VC lang tayo. Kaso nagkaroon tayo ng VX. And then, syempre, natutunan na rin naman natin sa nodal analysis, diba? Ang gagawin natin dyan is, hanapin ang branch kung nasaan si VX. Okay? Kunin ang branch kung saan nakatap yung itong dependent na to, saan siya itinap. So, dito yun sa branch na to. I'm going to copy this branch for you. Pero pwede nyo naman siyang i-analyze na lang mentally. Pero syempre, for the purpose of teaching, I have to show that to you. This is VB. This is the ground. And then here, merong nakatap na voltmeter, which is read as VX. Okay, ay sorry, bakit ba VB? Node B. And then the ground sa ilalim, ano. With this, kasi since KVL naman is flexible, it's up to you kung saan kayo maglulup. Pwede naman kayo mag-KVL dito. Kaya lang ang issue natin dyan is we have to have VX in our equation kasi kailangan mapalitan ito. Okay, kailangan yung equations natin sa KVL na to is VA, VB, VC lamang ang laman. So, ang target natin, ma-replace si VX. So, ganito ang gagawin natin. By nodal KVL, yung KVL ni nodal, dito tayo mag-loop sa labas. Kumbaga, iba-bypass natin yung resistor na nakalagay sa branch. Parang ang mangyayari dyan, kung dyan ka magki-KVL, that would be VB. Papasok sa positive, lalabas sa negative ni VX, no? So, minus VX, babalik ka sa ground, minus 0, and then equate to 0. And it would appear that VB pala is equivalent to VX, which means pwede mo itong isubstitute doon para maalis natin si VX sa ating equations. Although VX ang hinahanap ng problem, tanggalin natin siya kasi mahirap naman na lahat ng VB palitan natin ng VX pa. Ito papalitan pa, diba? Dito na tayo magpalit para isang equation lang yung papalitan natin. And then, going back to that equation, bali magiging ano yan? VA minus 3, magiging VB na siya, diba? Minus VB equal to 0, and if you simplify, you'll get that as VA minus 2VB equal to 0. And I'm going to underline this as our official third equation. So you have to pause the video again, and then press these equations in your calculator, 3 equations, 3 anos, to solve for VA, VB, VC. Pero, while you're doing that or before you do that, okay, let me just explain yung style ng pagkuha natin ng equations for the dependent voltage source using Kirchhoff's ano. Kasi baka baka sanay kayo sa Kirchhoff's, pwede nyo naman siyang gamitin ulit dito. So halimbawa, sa halip na binypass mo itong 10 ohms, sa halip na dito ka sa dumaan sa labas, dito ka sa loob lumabas, pwede mo namang gawin yon. Let me rewrite the circuit, diba? Kirchhoff style natin. Kirchhoff style of KVL for dependent is that we copy the circuit, we copy the resistance, and then we even copy the current that flows through it, which is I3. And then we attach the voltmeter, which is Vx. And then dito tayo magki-KVL, diba? Dito tayo magki-KVL. Okay, so if I do KVL using Kirchhoff's, that would be Vx minus 10I3 equal to 0, diba? Dito ako umikot pa ganyan. So, negative, positive lumabas, positive Vx. Kasabay ang current, kaya negative 10I3. Tapos ko na ang loop, kaya equate to 0. So, lalabas dito that Vx is actually equivalent to 10I3. Kaso, ano ba si I3? So, balik ka ulit sa circuit, i-trace mo ulit siya. At kunin mo yung Ohms law expression niya. I3 is VB minus Vx. Sorry. I3 is VB minus 0 all over 10 ohms. So, VB minus 0 over 10 ohms, it would appear that this is 10 times VB minus 0 over 10 ohms. So, kita mo, na-cancel lang si 10 at lalabas that Vx is also equivalent to VB, which is the same expression we got from here. By bypassing the resistance, nakuha pa rin natin siya. So, pinakita ko lang po yung difference. Okay? Now, these are your 3 equations again, and please solve them using your calculator. Okay? So, using our calculator, you'll be able to get 3 answers for VA, one for VA, one for BB, and then the other for VC. So, for VA, it should appear as 575 over 18. It should appear as 575 over 18 volts. For VB, it should appear as negative 575 all over 36 volts. And for VC, it should be 175 all over 36 volts. And since VB is equivalent to Vx, meron na tayong sagot. Therefore, Vx is simply equivalent to VB, which is also negative 575 all over 36 volts to answer the question of the example, which is determine Vx. So, this is our supernodal solution for a network with a dependent voltage source. Okay? And we now move to the last example that we have for this video, and this is an example that contains a current source naman, and at the same time an example that contains a dependent voltage source pero sa current source naman siya dependent. Yung isa kanina, dependent voltage source pero sa voltage siya naka-depend, naka-Vx siya. Ito naman, dependent yung voltage pero sa current siya naka-depend, which is this one. Okay, so let's proceed to our notes. And again, let's assign directions of currents and label our nodes. So for our node, let's say this is node ABCD. Of course, hindi ako pwedeng mag-reference sa BC kasi BC nodes contain the dependent voltage source. So you can either choose VA or VD. So, let me just choose VD as my reference, similar to the handouts that you have. And in this case, I'll assign directions of current. So, hindi na ako mag-a-assign for this branch because it already has IX. I'll assign at the remaining branches. So, this is I1. This is assigned I2. This one is I3. And then, ito ay inassign as I4. And then also at this branch, hindi na kailangan mag-assign because it already has an independent current source which is 5 amperes. After that, mentally short circuit na tayo for the supernode. So, that is supernodal BC. Diba? Supernodal BC. Ibig sabihin, you will take the branch as a short circuit and remove the 2ix dependent voltage source as a wire. Iso-short circuit na natin siya. So, isang wire na lang to. Meaning, dito tayo magki-KCL sa B at sa C. Okay? So, KCL at BC. Tingin muna tayo kay B. So, kay B, you have two branches, I1 and I2. And that means it's positive I1, negative I2. And then for node C, you have three branches para dyan. You have two branches. So, you have I3 at saka itong 5 amperes natin. So, I3 is negative. 5 amperes is also negative. Equate that to 0. Okay. So, for I1 flows from A to B. So, that is VA minus VB all over 5 ohms minus I2. For I2, that's B to ground. So, that's VB minus 0 all over 2 ohms. Okay, minus I3. I3 is from C to ground. So, that is VC minus 0. Diba? That is VC minus 0 all over. Add natin yung resistances na dinaanan. So, 5 plus 1, that is 6 ohms. Okay? Tapos, transpose ko na yung constant ko sa right para hindi ko na makalimutan as positive 5. Expand, you have VA over 5, negative VB over 5, negative VB over 2, negative VC over 6 equals positive 5. And then, we group together like terms. So, you have VA na 1/5. And then you have VB, dalawang terms yan. You have negative 1/5, tsaka negative 1/2. And then you have plus VC na negative 1 over 6 equal to 5. And this will be equation number 1. Okay? Next, we're going to take KCL at the remaining nodes. So, ang remaining node na lang natin is node A. So, we're going to take KCL at node A. Okay, if you take KCL at node A, it has 1, 2, 3 branches connected to it. And those are positive IX, negative I1, and positive 5 amperes. Equate that to 0. And then, substitute expressions ng Ohm's law, no? So, for IX, galing yan sa ground papunta sa node A. So, that's 0 minus VA all over 3 ohms. Minus, for I sub 1, that's A to B. So, you have there VA minus VB all over 5 ohms. Okay, equals, transpose the constant to the right, that's negative 5. Expand, you have negative VA over 3, negative VA over 5, and positive VB over 5. Don't forget to distribute the negative sign, and that would be equivalent to negative 5. Group together like terms. So, for VA, we have two terms, negative 1/3 and negative 1/5. Plus, for VB, you have there positive 1/5. And then equals that to negative 5. And this will be your equation number 2. Okay, equation number 2. After that, so tapos na tayo mag-KCL sa lahat. But obviously, you have 3 variables, VA, VB, VC. So after KCL, KVL naman tayo doon sa supernode branch. Okay, so KVL at BC, that will lead to VB minus 2IX minus VC, and then equate that to 0. So, as you can see, may kuryente pa dun sa equation natin, dun sa KVL natin. So, ang gagawin natin dito is replace IX by an Ohm's law expression. Trace nyo lang ulit. So, this will be VB minus 2 times IX is 0 minus VA over 3 ohms. Okay, minus VC equate to 0. After that, we expand. So, I'll start with VA na agad. This is negative, negative. So, magiging positive 2 times VA over 3. So, positive 2/3 VA. Okay, plus VB minus VC, and then equate that to 0. And this will be your equation number 3. And with 3 equations, 3 unknowns, please pause the video and type it in your calculator and check if you got the correct answer. If you did, your answers should be VA equal to 15 halves volts. VB must be negative 5 volts. And VC is equivalent to 0 volts. Okay? It's okay to have VCE. It's okay to have a node voltage that is equivalent to 0. Ibig sabihin, there is indeed zero potential sa side na yun. Ganun lang yun. So, ang target natin for this problem is to find the IX. So, yun ang isolve natin. For IX, tracing IX, that's 0 minus VA over 3. So, substituting, that's 0 minus VA, which is 15 over 2. All over 3 ohms, you'll be able to solve for IX. IX is equivalent to negative 5 halves amperes or simply negative 2.5 amperes. And as you can see, if the circuit has current sources, it's easier because you already have a constant value in your equation. If you have a circuit whose dependent voltage is whose voltage source depends on current, madali lang din, lalabas lang yung current na yun sa KVL mo, ang gagawin mo lang is paltan siya ng kanyang Ohms law equivalent, and then you'll have the complete set of equations that you need for the node voltages. And then, apply lang these values for the unknowns, in this case, which is IX. Okay? And that is how you do supernodal analysis. It's similar to your nodal, except that, ganun ulit. You're going to take the branch whose elements, or you're going to take all the branches whose contents are just voltage sources, walang kasamang resistor. And they can be considered supernode provided you're going to mentally short circuit them. Okay, mentally short circuit them. And make sure that these nodes are not your ground or your reference nodes. Okay? And that is again supernodal.